Have you ever felt like you need a secret decoder in just to understand all the buzzwords in AI? Yeah, me too. There's so much jargon flying around. But don't worry, today we're going to cut through all that noise and give you a simple, clear map to navigate this whole world. It's super easy to get lost, right? You hear AI, machine learning, deep learning, generative AI, agents, and they're all kind of thrown into the same bucket. But here's the thing, they're not the same. So think of this as our map making session. We're going to start with the biggest picture imaginable and then zoom all the way in to the really cutting edge stuff. All right, let's get into it. Our journey starts at, let's say, a 30,000-foot view, looking down on the entire continent we call artificial intelligence. First things first, AI is the whole shebang. It's the big umbrella term for the entire field of trying to make computers smart. Basically, anytime we teach a computer to do something that a person is naturally good at, like recognizing a face in a photo, understanding what you're saying, or spotting a weird pattern in a bunch of numbers, that's AI. Now, let's zoom in a bit. Inside that giant continent of AI is a massive, incredibly important country called machine learning. And this is where things get really cool. See, instead of a programmer writing out every single step, every single rule, we just feed the machine a ton of data and let it figure out the patterns on its own. It literally learns from experience, not from a rule book. And if we zoom in one more level, we find deep learning. This is a superpowered, specialized type of machine learning, and it is the engine behind almost every mind-blowing AI breakthrough you hear about today. It uses these complex structures called neural networks, which are, and this is so cool, loosely inspired by the way our own brains are wired, allowing them to process information in a much more sophisticated, layered way. Okay, so how does this whole learning thing actually work? Well, it's a complete 180 from how we've built software for decades. And this slide nails the change perfectly. In old school programming, we the humans write the rules. We define the logic, we give it some input, and the computer spits out an answer. Simple. But with machine learning, we flip the script. We give the computer the inputs and the answers we want. The machine's job is to look at all those examples and figure out the logic, the rules that connect them. It literally works backward to figure things out. So one way it learns is through what's called supervised learning. Think of this like studying with a complete answer key. The classic example? Your email spam filter. We feed the program thousands and thousands of emails that we've already labeled for it. This one's spam. This one's not spam. It just studies them, finds all the tells, like weird phrases or shady links, and eventually learns to spot spam all by itself when a new email comes in. But what happens when you don't have a neat little answer key? Well, that's unsupervised learning. Picture this. You give a kid a giant, messy pile of toys and 2 empty boxes. No instructions. What do? Well, they might start sorting by color, or maybe by size, or maybe they put all the cars in one box and all the dolls in another. They find the hidden patterns all on their own. That's exactly what an AI does here. It finds hidden groups and structures in data without any help from us. Okay, so that's great for nice, clean, organized data, but what about the messy stuff, like photos, audio clips, or just plain text? For that, we need the real brain of the operation, deep learning. I mean, really think about it for a second. To a computer, a photo is just a giant grid of colored pixels. There's no pointy ears column or whiskers row. A traditional program would have no idea where to even start. To recognize a cat, the machine needs to learn how to build up an idea, starting from the most basic little lines and shapes and ending with a complex concept, just like our brains do. And this koala team analogy is a perfect way to picture it. Imagine you have a team of students. The first group in the line can only spot simple things, like little curves and edges. They pass their findings to the next group, which combines those edges into bigger shapes, like an eye or a nose. That group passes its findings on, and the next one combines those into the idea of a face. Finally, the person at the end of the line makes the call. Yep, that's a koala. Or, nope, not a koala. But here's the magic part. If they get it wrong, feedback goes all the way back down the line, and every single student adjusts their strategy just a little bit. That's learning. That's a neural network. Now, deep learning was already incredibly powerful, but then one specific design, one particular architecture came along and changed everything. It's called the transformer. Its big breakthrough was a new way of understanding context, how all the words in a sentence relate to each other. And I'm not exaggerating when I say this. This innovation is the single biggest reason we're in the middle of this AI explosion right now. Because that transformer breakthrough unlocked a completely new kind of AI capability. All of a sudden, the focus shifted from just analyzing the world's information to actually creating brand new things. And that brings us to generative AI. This is the AI that doesn't just predict or classify, it actually generates new stuff. When you ask ChatGPT to write a sonnet about your dog, or when you see those incredible videos of a woolly mammoth walking through a snowy field, that's generative AI. It's creating something totally original based on the countless patterns it learned from all the data it was trained on. So, how on earth does it do that? Well, a really useful, if slightly cheeky analogy for the models behind this, which are called large language models, or LLMs, is a stochastic parrot. Just imagine a parrot that has somehow heard every single book, article, and conversation ever recorded. It doesn't actually understand what love or sadness mean, but it's an absolute genius at knowing which word is statistically most likely to come next in any given sentence. It's the most sophisticated mimic you can possibly imagine. So let's just put this side by side to make this shift crystal clear. Traditional AI was all about analysis and prediction. Its output was a label or a number, like spam or not spam. But generative AI, its purpose is to create something brand new. Its output is a paragraph, a photorealistic image, or a chunk of computer code. They're just built for fundamentally different jobs. But the evolution doesn't stop with creating things. Nope. The next frontier, the thing that everyone is racing towards right now, is moving from just answering our questions to actually doing things for us. Welcome to the world of AI agents. Let's walk through this with a quick example. Let's say you have an HR assistant. At level 1, it's basically a smart search engine. It can read all your company's HR documents and answer a question like, "What's our policy on vacation days?" It's just finding and summarizing information that already exists. Okay, level 2 is where it gets more interesting. Now the assistant can connect other tools. It can actually log into the HR system, check your personal leave balance, and then use another tool to fill out and submit the time off request for you. See the difference? It's not just talking anymore, it's taking a simple action. But an agentic AI? Well, that's a whole other league. You don't give it step-by-step instructions. You just give it a goal. A goal like, onboard the new intern. The AI then thinks for itself. It comes up with a whole plan. Okay, first I need to schedule a welcome meeting. Then I'll file an IT ticket for a new laptop. Then I have to request access to these 3 software systems. And then it goes and does all of those things, using the tools it has available. So what really defines an AI agent is this autonomy. They aren't just reacting to a command. They are proactive and goal-oriented. They can reason through complex, multi-step problems, make decisions on their own about what to do next, and use a whole suite of tools to actually get the job done, all without a human holding their hand. And there you have it. Our map is complete. We've traveled all the way from the vast continent of AI through the country of machine learning down into the powerhouse region of deep learning, and we've explored the buzzing cities of generative AI and the really exciting new frontiers of agentic AI. And that journey leads us to one final huge question. We started with machines that could just classify things. Now we have machines that can create original art and autonomously act on our behalf. So if an AI can take a high-level goal and just figure out how to achieve it, the only real question left is, what are we going to ask it to do next?